What is the function of a diode and its uses?
Diode is one of the types of semiconductor parts that are used in many electronic circuits, and it conducts the electric current in one direction and prevents the current from passing through the circuit in the opposite direction. In fact, a diode is a two-terminal solenoid valve that moves current in one direction. These parts are made of various semiconductor materials such as silicon or germanium. They are formed by connecting two impurity regions P and N. For a better understanding diode, we need to know how P-N junctions work in semiconductors.
The internal structure of the diode. P-N junctions in semiconductors are created by a process called doping.
Investigating the topic of making P-N junctions is very specialized and is far from the topic of this video. But in short, it can be said that in this process, impurities of N and P type are placed on the sides of the junction and create empty holes and free electrons. These holes and free electrons at the junction of two areas N and P are attracted to each other and form a special region that has a completely neutral electric charge. This neutral region in P-N junctions is called the depletion region. The existence of this area with a certain width is the main reason for current passing through one side and not passing through the other side of the diode.
To create the P region, gallium, aluminium, and boron, impurities can be added to the semiconductor material. Due to the addition of these materials, a large number of holes are created in this region. The P region in a diode is known as the anode, and it forms its positive pole. Impurities such as phosphorus, antimony, and arsenic are used for the N region, which increases the number of electrons in this region. Therefore, each type of diode, regardless of its special features, has two bases called anode and cathode. According to the different load on the two bases of the diodes, two types of bias can be considered for them, which we will introduce. One. Forward bias.
In the equilibrium state of this device, there are no electrons between the anode and cathode regions until a forward bias voltage is applied to it and current flows through it. Direct bias means the situation where the positive end of the diode, anode, is connected to the positive end of the power source and its negative end, cathode, is connected to the negative end of the power source. The level of discharge is greatly reduced and the base electrons of the anode move easily to the holes of the base of the cathode and the diode passes the current, and as you can see, the circuit is completely established.
Two. Reverse bias. If we reverse the direction of the supply applied to the diode and connect the positive terminal of the power supply to the N region and its negative terminal to the P region, it causes the holes to retreat to the other side of the connection and the electrons. It will move in the opposite direction. This happens, very little current flows through the PN junction and the width of the discharge region becomes much larger. As this area becomes wider, it becomes harder for the current to pass, and in fact the diode does not allow current to pass through itself, which leads to this. This is called reversal bias. In this case, the circuit is not established. The use of diodes in reverse bias may cause the breakdown of the drain region and the so-called burning of the diode. Special diodes such as Zener or Avalanche can take the direction of the reverse current and be used in this situation. Diode circuit symbol.
In most diodes, there is a gray band at one end of the piece that indicates the direction of the cathode. Its circuit symbol is a triangle that points to the cathode and a line is perpendicular to its tip. This symbol indicates that the conventional current in the circuit. It is directed from the anode side to the cathode side. We know that in practice, the electrons of the circuit move from the negative side to the positive side, but by convention, the direction of current flow is against the movement of electrons.
How does a diode work?
The function of these parts in a nutshell is that they pass electric current in forward bias and act like an open switch in reverse bias. The voltage current diagram means that in the case of forward bias, as the voltage increases, the amount of current through the diode increases almost linearly. It is like an open circuit. According to the structure of the semiconductors inside, each diode has the ability to withstand reverse bias up to a certain voltage, which is called the breakdown voltage, VBR.
Types of diodes. Diodes have different models and types, and to know the reason for using each one, we must be familiar with their structure. Stay with us to check the important and practical types of this part. PN junction diode.
This type is actually the same diode that we talked about at the beginning of the video and learned about its function. This family of diodes is sometimes called silicon diodes. The PN junction diode is one of the simplest types of diodes used for rectification, voltage regulation, and signal detection applications in circuits.
Schottky diode.
This model is made by connecting a semiconductor and a conductor. Usually the metal used is molybdenum, platinum, chromium or tungsten, and an N-type semiconductor. Schottky diodes have lower voltage drop than conventional silicon diodes at low currents. They may have a voltage drop in the range of 0.14 to 0.4 volts. While the corresponding voltage for silicon diodes is in the range of 0.6 to 1.7 V, they have much higher switching and in addition to rectification. This type of diode is used in circuits that require fast switching.
Zener diode.
A Zener is a type of diode used in the reverse region, meaning that in addition to passing the current in the direct mode like other normal models, by applying a fixed and specific amount of reverse bias, it passes the same current in the opposite direction. In fact, the main use of Zeners is to use them in reverse bias mode. where they pass a large current for a nearly constant voltage. This breakdown voltage is known as the Zener voltage, and it will be from 1.7 to 200 volts based on the structure of the diodes, which is used as a voltage reference in circuits. Zeners are used for signal clipping, shifters and voltage regulators.
Avalanche diode. This family is used similarly to Zeners in the reverse region, and their difference is that they have a larger breakdown voltage. These diodes are designed to fail at a certain voltage and not be damaged. Avalanche diodes are used for protection applications, inductive circuits and high voltage circuits. Varactor diode.
The capacity of this capacitor is proportional to the value of the variable voltage, and for this reason, this diode is also called a variable capacitor. Vectors are used in tuning circuits and filters.
The operation of the capacitor diode is in two modes. If high voltage is applied to both ends, its capacity will decrease. If the voltage decreases, the vector capacitance increases. In any circuit where the capacity of the capacitor must change according to the voltage value, a capacitor diode is used. Tunnel diode.
Tunnel diodes are also a PN semiconductor junction with the characteristic that they operate based on the mechanical tunneling property of electrons from the potential barrier. A tunnel diode provides negative resistance in the voltage range used for oscillators, amplifiers, and switching, and is used for very fast circuits.
Pin diode.
The name of this diode is based on its internal structure. Its N and P regions are similar to conventional diodes, except that between these two regions there is an intrinsic semiconductor part without doping process. This region is similar to the wide depletion region and strongly weakens the rectification, but it is used for applications such as fast switching, attenuation, light detection and high-voltage circuits of power electronics.
Gun diode.
GaN diodes are also known as electron transfer devices, TEDs. They are a type of diode that produces microwave signals by exploiting the GaN effect. The GaN effect is a phenomenon in which a high electric field applied to certain semiconductors, such as gallium arsenide, GauZ, causes electrons to move through the material with a negative differential resistance, and oscillates at microwave frequencies. Unlike other diodes, the GaN has a negative semiconductor region with resistive junctions at both ends.
LED.
The name of this model is derived from the term light-emitting diode, and it is one of the most widely used types of diodes. In the simplest terms, a light-emitting diode, LED, is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor material. LEDs emit light in the visible light range when connected to forward bias and current flows through them. Making indicator, display and lighting is one of the applications of LED.
Photodiode.
This model is used for light detection. The function of these diodes is that due to light radiation, electrons and holes are created in them. This action creates a current in the circuit. In other words, it can be said that photodiodes have the opposite function of LEDs. Photodiodes are usually used in reverse biased conditions so that the very small current induced by the light radiation can be easily measured. Photodiode applications include light detection sensors, optical communications, and solar cells.
Laser diode. This type of diode emits light similar to LED, except that it shows coherent light. This model is used for applications such as DVD and CD drivers, point laser pointers, etc. Today, it is one of the most widely used types of lasers. Backward diode.
This diode is a special type of Zener family diodes. In reverse bias, it is used in very low reverse voltages, in the range of 10 volts, and a very high current passes through it. As the voltage increases, less current passes through it. The working range of this diode is about 0.1 to 0.7 volts. This family can be used in high-speed switching circuits.
Small signal diode. These types of diodes belong to the family of PN junctions, the width of which is very small. For this reason, they are capable of operating in high frequency and high speed switching and work in very low voltage and current ranges. The reason for naming this diode comes from the fact that it works in the range of milliampere current. What are the uses of the diode? Diodes have many applications in electronics and electrical engineering, some of which are rectifier. Usually diodes are used to convert AC voltage to DC voltage in power supplies. Voltage regulation. Zener diodes and other types of voltage regulating diodes can be used to maintain a constant voltage in a circuit, even when the input voltage varies. Signal detection. Diodes can be used to detect the signal in the circuit by rectifying and filtering it. Signal cutoff or limiting. Diodes can be used to cut off or limit the range of a signal to prevent distortion or damage to the circuit. Switching. Since diodes allow current to flow through the circuit in only one direction, they can be used as switches in electronic circuits. Protection. Diodes can be used to protect circuits against surges and reverse voltage. Lighting. Light-emitting diodes, LED, are used in a wide range of lighting applications. Solar cells. Photodiodes and other types of semiconductor diodes are used in solar cells to convert light energy into electrical energy. Microwave applications. Gun diodes and other types of diodes are used in microwave applications such as amplifiers, oscillators, and detectors. Communications. Laser diodes are used in optical communication systems such as fiber optic networks. To support me, subscribe to my channel. Like my videos. Press the bell button for notifications. Subscribe to my channel for new videos. Share my videos. Write me a comment. Thank you. For more specialized information about each electronic component, refer to the technical and specialized training playlist of the components.